To verify a ground connection in a 120 volts outlet using an Ohm-Meter, several steps must be followed to ensure safety and accuracy. Firstly, gather the necessary materials, which include an Ohm-Meter and safety glasses. Secondly, prior to commencing any testing, it is imperative to adhere to strict safety precautions. Wear safety glasses to protect your eyes and ensure the outlet is de-energized before proceeding. Exercise caution when working with electrical equipment. Now let's proceed with the steps. 1. Turn off the power to the outlet. Locate the breaker or fuse that controls power to the outlet and turn it off. 2. Remove the outlet cover. Carefully pry off the cover plate to expose the outlet terminals. 3. Identify the ground terminal. The ground terminal is typically bare or green insulated and located on the top or bottom of the outlet. 4. Set the Ohm-Meter to the lowest resistance setting. Most Ohm-Meters have multiple resistance settings. Select the lowest setting, typically labeled ohms or omega. 5. Connect the Ohm-Meter to the ground terminal and a known ground source. Touch one probe of the Ohm-Meter to the ground terminal of the outlet. The other probe should be connected to a known ground source, such as a metal water pipe or the ground rod of the electrical panel. 6. Check for continuity. If the ground connection is intact and sufficient, the Ohm-Meter will display a low resistance reading, typically below 1 ohm. 7. Verify the ground wire continuity. If the Ohm-Meter reading is high or infinite, it indicates a possible break in the ground wire. To check this, touch one probe of the Ohm-Meter to the ground terminal and the other probe to the ground wire connection at the electrical panel. A low resistance reading confirms continuity. 8. Reassemble the outlet. If the ground connection is verified, replace the outlet cover. Now let's discuss acceptable readings. A good ground connection will typically show an Ohm-Meter reading below 1 ohm. A possible ground fault may be indicated by an Ohm-Meter reading between 1 and 10 ohms. No ground connection will be indicated by an Ohm-Meter reading above 10 ohms or infinite. Note that if you do not have a known ground source to reference, you can connect both probes of the Ohm-Meter to the ground terminal. If the reading is low, it indicates a good ground connection. However, this method is less accurate than using a known ground source. When using an Ohm-Meter to verify a ground connection, it is essential to understand the principles behind the measurement. An Ohm-Meter measures electrical resistance, which is the opposition to the flow of current in a circuit. A good ground connection should have very low resistance, ideally close to 0 ohms, as it provides a direct path for fault current to flow back to the source, allowing protective devices like circuit breakers or fuses to trip and energize the circuit, thereby preventing electrical shock hazards. The National Electrical Code, or NEC, provides guidelines and standards for electrical installations to ensure safety. While the NEC doesn't specify a precise resistance value for ground connections, it emphasizes the importance of a low impedance ground path. A reading below 1 ohm is generally considered acceptable and indicates a solid ground connection. However, higher resistance values may indicate a potential problem with the grounding system. Several factors can affect the resistance of a ground connection. Corrosion, loose connections, and damaged wiring can all increase resistance. Therefore, it's crucial to inspect the grounding system periodically and address any issues promptly. Grounding electrodes, such as ground rods or metal water pipes, are used to establish a connection to the earth. These electrodes provide a low resistance path for fault current to flow into the ground. The NEC specifies the requirements for grounding electrodes, including their size, material, and installation depth. When testing the ground connection with an Ohm-Meter, it's important to ensure that the power to the circuit is turned off to prevent damage to the meter or injury to the user. Additionally, it's recommended to use a calibrated Ohm-Meter to ensure accurate readings. The Ohm-Meter should be set to the lowest resistance range to provide the most precise measurement. When connecting the Ohm-Meter probes to the ground terminal and a known ground source, make sure the connections are clean and tight. Loose or corroded connections can introduce additional resistance and affect the accuracy of the measurement. If the Ohm-Meter reading is high or infinite, it indicates a possible break in the ground wire or a poor connection. In this case, it's necessary to inspect the grounding system to identify and correct the problem. Check for loose connections at the outlet, the electrical panel, and the grounding electrode. Also, look for any signs of corrosion or damage to the ground wire. If the ground wire is broken or damaged, it should be replaced with a new wire of the same size and type. When reassembling the outlet, make sure all connections are tight and secure. The outlet cover should be properly installed to protect the terminals and prevent accidental contact with live wires. In addition to using an Ohm-Meter, there are other methods for verifying the ground connection in an outlet. One method is to use a receptacle tester, which plugs into the outlet and indicates whether the ground connection is present and properly wired. Another method is to use a ground fault circuit interrupter, or GFCI tester, which simulates a ground fault condition and verifies that the GFCI trips and energizes the circuit. These testing methods can provide additional assurance that the ground connection is functioning correctly. Maintaining a proper ground connection is essential for electrical safety. A well-maintained grounding system protects against electrical shock hazards, prevents equipment damage, and reduces the risk of fire. Therefore, it's important to periodically inspect and test the grounding system to ensure that it's functioning correctly. If you are not comfortable working with electrical equipment, it's recommended to hire a qualified electrician to perform the inspection and testing. Electricians have the knowledge, skills, and equipment necessary to safely and accurately assess the grounding system and make any necessary repairs. The principles behind using an Ohm-Meter to verify a ground connection rely on understanding electrical resistance and continuity. Resistance, measured in ohms, quantifies the opposition to current flow in a circuit. A good ground connection should exhibit very low resistance, ideally approaching 0 ohms, providing an unimpeded path for fault current to return to the source. This low resistance enables protective devices, such as circuit breakers or fuses, to quickly detect and interrupt the flow of electricity during a fault condition, thereby minimizing the risk of electrical shock and equipment damage. Conversely, a high resistance reading indicates a compromised or non-existent ground connection, rendering the protective devices ineffective and increasing the potential for hazardous situations. Continuity refers to the presence of a complete and unbroken path for current flow. In the context of ground connections, continuity testing verifies that the ground wire is intact and provides a continuous path from the outlet to the grounding electrode system. An ohm-meter is used to measure the resistance of this path. A low resistance reading confirms continuity, while a high or infinite resistance reading indicates a break in the ground wire or a faulty connection. The NEC establishes standards for grounding and bonding to ensure electrical safety. Grounding refers to the intentional connection of a circuit or equipment to the earth, while bonding involves connecting conductive parts to create an electrically conductive path. The NEC specifies requirements for grounding electrodes, grounding conductors, and bonding jumpers to establish a low-impedance ground path. Following these requirements is crucial for minimizing the risk of electrical shock and ensuring the proper operation of protective devices. The ground terminal in an electrical outlet is typically identified by its green color or bare metal appearance. It is connected to the grounding conductor, which runs back to the electrical panel and is ultimately connected to the grounding electrode system. When testing the ground connection, it's important to ensure that the Ohm-Meter probes make good contact with the ground terminal and a known ground source. Clean any corrosion or debris from the terminals to ensure accurate readings. If a known ground source is not available, an alternative method is to connect both Ohm-Meter probes to the ground terminal. A low resistance reading in this configuration indicates that the ground terminal is connected to the grounding system, although it doesn't verify the quality of the ground connection as accurately as using a known ground source. In addition to verifying the ground connection with an ohm-meter, it's also important to visually inspect the grounding system for any signs of damage or deterioration. Check the ground wires for cuts, abrasions, or corrosion. Inspect the grounding electrode for proper installation and condition. Ensure that all connections are tight and secure. Any issues identified during the visual inspection should be addressed promptly to maintain the integrity of the grounding system. Regular testing and maintenance of the grounding system are essential for ensuring electrical safety. The frequency of testing and maintenance depends on the environment and operating conditions. In harsh environments such as those with high humidity or corrosive atmospheres, more frequent testing and maintenance may be required. A qualified electrician can provide guidance on the appropriate testing and maintenance schedule for a particular installation. When working with electrical equipment, it's always important to follow safe work practices. To energize circuits before working on them. Use insulated tools. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical equipment, hire a qualified electrician to perform the work. Understanding the principles of grounding and bonding and following safe work practices are essential for preventing electrical shock and ensuring electrical safety. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Understanding acceptable resistance readings is vital for interpreting Ohm-Meter measurements. As mentioned earlier, a reading below 1 ohm typically indicates a good ground connection. This low resistance value signifies that the ground path is capable of effectively conducting fault current back to the source, facilitating the rapid operation of overcurrent protection devices. A reading between 1 and 10 ohms raises concern and suggests a possible ground fault. This elevated resistance might be due to loose connections, corrosion, or a partially damaged ground wire. Further investigation is necessary to pinpoint the source of the increased resistance and rectify the issue. A reading above 10 ohms or an infinite reading signifies a non-existent or severely compromised ground connection. This situation poses a significant safety hazard, as fault current cannot effectively return to the source, rendering overcurrent protection devices ineffective. Immediate action is required to restore a proper ground connection. The accuracy of the Ohm-Meter is paramount for obtaining reliable measurements. Ensure that the Ohm-Meter is properly calibrated and functioning correctly. Prior to taking measurements, zero the Ohm-Meter to compensate for any internal resistance. Use high-quality test leads and ensure that the connections between the test leads and the circuit are clean and tight. Avoid using excessive force when connecting the test leads, as this can damage the terminals. If the Ohm-Meter displays erratic or unstable readings, check the battery and the test leads for any issues. A low battery or faulty test leads can affect the accuracy of the measurements. Remember that an Ohm-Meter measures resistance only when the circuit is de-energized. Never use an Ohm-Meter on a live circuit, as this can damage the meter and pose a safety hazard. Always verify that the circuit is de-energized before taking any measurements. The importance of proper grounding and bonding cannot be overstated. A well-designed and properly maintained grounding and bonding system is essential for electrical safety. It protects against electrical shock hazards, prevents equipment damage, and reduces the risk of fire. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices to quickly interrupt the flow of electricity. Bonding ensures that all conductive parts are at the same potential, minimizing the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding. These requirements cover various aspects of electrical installations, including grounding electrodes, grounding conductors, bonding jumpers, and equipment grounding. Following the NEC requirements is crucial for ensuring the safety and reliability of electrical systems. Regularly inspect and test the grounding and bonding system to ensure that it is functioning correctly. Look for any signs of damage, corrosion, or loose connections. Use an Ohm-Meter to verify the continuity and resistance of the grounding conductors and bonding jumpers. Address any issues promptly to maintain the integrity of the grounding and bonding system. If you are not comfortable performing electrical work, hire a qualified electrician to inspect and maintain the grounding and bonding system. A qualified electrician has the knowledge, skills, and experience necessary to ensure that the electrical system is safe and reliable.